12,500 feet below the surface of the North Atlantic, the ocean floor is pitch black. But thanks to millions of data points gathered by modern submersibles, we can finally see what rests there in perfect clarity. But this shipwreck is disappearing. Deep-sea bacteria are aggressively eating the steel, turning the massive hull into fragile rusticles that could collapse into unrecognizable dust at any time. Knowing the clock is ticking, a 2022 deep-sea mission spent weeks scanning the entire debris field. They created a permanent, millimeter-accurate digital replica of the site, capturing the ship exactly as it sits before the ocean claims it completely. The resulting dataset provides a new vantage point for forensic analysis. The 3D model allows investigators to trace the sinking back to specific metallurgical flaws, engineering oversights, and command decisions that were previously invisible. If we move the virtual camera along the starboard side of the digital hull, we can zoom in on the exact point where the ship struck the iceberg. The water that night was freezing, around -2 degrees Celsius. Metallurgical analysis by the National Institute of Standards and Technology revealed that at those temperatures, the specific steel used for the ship's hull plates became highly brittle, losing its ability to bend and absorb impact. Looking at this archival image of the damage to the Titanic's sister ship, the Olympic, we can see exactly how the metal reacted to extreme stress. When the Titanic scraped the iceberg at over 20 knots, the violent force popped the interior heads clean off the iron rivets holding the ship together. Without those rivets holding the tension, the massive steel plates buckled and parted under the pressure. This created a series of narrow, localized slits along the seams, allowing thousands of tons of ocean water to rush in. This supposedly impenetrable hull gave way because of microscopic weaknesses in the metal. The steel shattered when it should have deformed, and the rivets snapped when they should have held. A hull breach alone shouldn't have doomed the vessel. To understand why it went down, we have to look past the steel and examine the internal defense systems. The ship's lower section was heavily reinforced with a double bottom and divided into 16 watertight compartments. The engineers calculated that even if 4 of these massive rooms completely filled with water, the ship would stay afloat. This diagram illustrates their fatal miscalculation. The designers tested their safety measures using a purely static engineering model. They ran their numbers assuming the ship would sit perfectly flat and horizontal in the water, no matter how much it flooded. That isn't how physics works. As thousands of gallons weighed down the bow, the ship pitched forward into the ocean. Because the walls dividing the compartments did not reach all the way to the ceiling, the rising water spilled over the top of one bulkhead and cascaded into the next, exactly like water filling a tilted ice cube tray. The engineers analyzed a moving object as if it were standing still. That single oversight turned a highly advanced compartmentalized defense into an unstoppable chain reaction. Moving up from the hull into the digital scan of the bridge, researchers found the telemotor, the exact piece of steering equipment where officers stood making their final command decisions. The physical evidence points to structural failure, but the command log reveals a series of fatal choices. Under the authority of Captain Edward Smith, the crew received multiple radio warnings about heavy ice in their path. Despite this, they maintained a speed of nearly 22 knots, pushing the engines to their limit through a known hazard zone. The men stationed in the crow's nest to spot these icebergs were working entirely with the naked eye. The key to the locker containing the ship's binoculars had been misplaced before they ever left port, and if the worst did happen, the ship was completely unequipped for an evacuation. Even though the manifest listed over 2,200 passengers and crew, the deck was outfitted with just 20 lifeboats, barely enough to carry half the people on board. Material and engineering failures broke the ship's structure, but the lack of emergency equipment and overconfident command decisions transformed a mechanical failure into a mass casualty event. By 2:18 a.m., the flooded bow was submerged so deeply it pulled the stern high into the air. The physical strain on the midsection was too much for the iron structure. With a screech of twisting metal, the hull snapped completely in half. Both halves plummeted to the seafloor, leaving over 1,500 people adrift in the dark. In water that cold, the human body shuts down fast. Almost all of those left behind succumbed to rapid hypothermia within 15 to 30 minutes. The scale of the disaster was impossible to ignore. The The public outcry forced governments across the globe to convene and completely rewrite the rules of maritime travel. This modern image shows a Coast Guard plane executing an active iceberg patrol, a direct consequence of the sinking. Safety regulations now dictate that every commercial vessel must carry enough lifeboats for every single soul on board. Ships are required to maintain 24-hour radio monitoring, and an international task force tracks ice hazards across the shipping lanes. The physical remains of the Titanic will eventually rust away into nothing, but the millimeter-accurate digital ghost mapping its autopsy and the strict safety laws passed in its wake serve as a permanent reminder. Arrogance is heavy, and no human creation is ever truly unsinkable.